Now, going ahead, we'll be looking into the Van Neumann model. So, why this model was being implemented. Now, the basic reason to implement Van Neumann model was it was to overcome the problem of fixed programs, which we'll be seeing in the upcoming slides. And there were certain limitations which an ENIAC computer had. So these limitations were being overcome by the Van Neumann model. So let us go ahead and look at these topics one by one. So in 1946, John von Neumann and his colleague began to design a new stored program referred to as IAS, which is called as Institute for Advanced Study Computer. Now, the basic advantage of using the Van Neumann model was it stores the program and data in the same memory. So when you're storing the program and data in the same memory, the retrieval of the data becomes fast, the memory occupancy becomes less, and time for execution of the particular instruction also increases. The output is also increasing. Now, the main intention to design Van Neumann model was to overcome the limitations which the previous model of the ENIAC computers had. Now, what was that limitation the ENIAC computer had? The task of entering or altering. Altering means if you want to change the program, it was extremely tedious in case of the ENIAC computers. Now, if you have stored the data, the system will start performing according to your stored instructions. But at the same time, if you want to change the data, it becomes a tedious task, and hence Van Neumann model was being brought into picture. Now, first of all, let us understand what do you mean by fixed programs. These are very specific programs and they perform a very specific operations. For example, the work which you do on a calculator, you can do the binary calculations on it. But when you try to go beyond the calculation, the calculator is not able to compute it. It is also doing the basic mathematics, but it cannot use a word processor or a gaming console. So this becomes the limitations of a calculator. Changing the program of a fixed program machine requires rewiring, restructuring, redesigning. So if you want to change the program of a calculator, imagine if you want to include word processor, gaming console in the calculator, what all tasks we need to do? Rewiring, restructuring, redesigning, altering the entire concept of the machine, and then come out with a super calculator. So it will take weeks of time. And if you want to perform the above task, what we discussed, in case of an ENIAC, it will take at least 3 weeks to get the ENIAC working. So imagine the type of efforts you are putting and the time required for those efforts to become fruitful. Now, the stored programs. When we say stored program, it means that the data is getting stored in the form of memory. A stored program computer is not only that stores program in the electronic memory, but these are the programs that are reprogrammable. It can get customized. These programs are not the static programs. These programs are dynamic programs, which can be customized according to the requirement and according to the status. Van Neumann is a stored program architecture, also known as Prince-Stone architecture, which was being introduced by John Neumann, which we have seen, a Hungarian-American mathematician, physicist, and a computer scientist. Now, if you look, there were two advantages in these two slides, what we have seen of Van Neumann. One is the programs are dynamic. You can reprogram it. and the time of execution is very, very less as compared to the ENIAC machines. Now let us consider and look into the Van Neumann architecture. It consists of input CPU, that is central processing unit, and then directly to the output. Now the central processing unit is consisting of subparts, which is called as the control unit, arithmetic and logic unit, the different forms of registers, and then the memory unit. The memory unit directly interacts with the CPU, and the CPU interacts with the input-output and input-output devices, which are being interlinked with each other. Now, the basic concept behind the Van Neumann architecture is the ability to store program instruction in memory along with the data. So data and program instructions are getting stored into the same memory on which the instructions are operating continuously. The Van Neumann architecture also describes a general framework. It will give you a general framework that consists of mainly the three parts: the hardware, the programming, which is the software, and the data that should be allowed to flow. It also allows computer and mobile devices are redesigned on the basis of the fundamental concepts. There are basically three types of the basic components. One is called as I/O interface. The second is called as the CPU. The third is called as a memory. Now your buses are responsible to carry the data. So what are those buses that are responsible for carrying the data from one place to other place? The thing that should come to your mind is it is the system bus. In system bus, it is the address bus, data bus, and the control bus that are responsible for the flow of data from one destination to the other destination. Now, what are the different types of I/O interfaces? Now, we have seen I/O interface that allows the computer memory to receive the information and send the data to the output devices. It also allows the computer to communicate to the user to secondary storage devices like the disk and the tape drive. These are also called as the I/O peripherals, where the I/O interfaces act as a pipe so that you can share the data onto your other interfaces also, which are being interlinked with each other. Now, what is central processing unit? The central processing unit basically consists of the three factors. You have the control unit, you have the arithmetic and logic unit, and then you have the registers. So let us go ahead and look at it. What does the control unit do? What does the ALU does? What does the work of registers? The control unit is responsible for decoding the instruction and controlling how data moves around the computer. So you should first understand that control unit is directly linked with ALU, registers, and different memories. And it has a bus that is called as the control bus. The control bus mainly is responsible for transferring of data from one source to the other destination. And control unit takes care of those transfer. The execution of each instruction is determined by a sequence of control signals produced by the control unit. Arithmetic and logic unit. It carries out the calculation and it carries out the logical decisions required by the program instruction. So it will decide what type of instructions need to be performed, whether it is an arithmetical unit program or a logical program that needs to be operated. The input to an ALU are the data to be operated called as operands, and the code indicating the operation to be performed. The ALU output is the result of the performed output or performed operation. So after the operation is being performed by the ALU unit, you will get the desired output and result, which needs to be performed, and what output you have gained in the form of the performed operation. Now, CPU on the further division is called as registers. Registers are the place where you have memory location for the specific purpose. So why do you require registers? It is mainly used for the storage of data, or it is can be defined as the place or space required for the storage of data. Now registers are being further classified into accumulators, program counters, memory address register, memory data register, current instruction register. Now let us go ahead and look at it one by one. Accumulator. It stores the result of calculation made by the ALU, that is temporary. It will store the result, what the output it has gained from the accumulator. Program counter, it will keep a track of location for the next instruction to be dealt with. The program counter then passes this instruction to the memory address registers. Now, why program counter is responsible? Because it will keep the tracking of what instructions are being executed and what instructions are being passed to the memory address registers. Now, memory address register will store memory location for data or instructions that needs to be fetched from memory or stored into the memory. So it will check whether the instruction is a valid instruction or not, which came to the address, and then it will decide to store the data into the memory or fetch the data from some memory. It may be a cache memory or the auxiliary memory which have been connected. Memory data register, it stores data or instructions fetched from memory or any data. It is to be transformed and stored in the memory. And then you have the current instruction register. It will store the most recently fetched instruction while it is waiting to be executed or to be decoded. So the most recent instructions will be executed in the form of CIR. Now, what is a memory? The computer's memory is used to store programs. We are aware of this in the form of instructions and data. It consists of memory cells. It may be a fixed size cells, and each cell is associated with it. Two of the most commonly used types of memory are random access memory or secondary memory. So what do you understand by random access memory? It is called as the memory which has been basically used for the computers to store the data. Now, what are the basic functions of random access memory? So, random access memory is a form of computer memory that can be read and changed in order to typically use to store working data and the machine codes in the system. Now, what was the advantage of von Neumann architecture? The first advantage: control unit gets data and instruction in the same way from one memory. It simplifies design and development of the control unit. So the control unit is more simplified. The other advantage is it is customizable, and the instructions here are not static. It is dynamic. So you can easily code your instruction to get out the desired output and result. Data from memory and other forms of devices are accessed in the same way, and memory organization is in the hands of the programmers. So programmers can decide whether they want to use the static memory or the dynamic memory, or they want to release the memory for some other operations of computing to take place. Now, as we have seen the advantages, so there were certain disadvantages also of the von Neumann architecture. Serial instruction processing does not allow parallel execution of the program. So parallel execution was a complex task and it was not been allowed by the system. Parallel executions are simulated by the operating system. One bus is a bottleneck. Only one information can be accessed at one time. So if you want to access multiple instructions at one time, then von Neumann architecture would take more time, because as soon as one instruction gets over, then it goes to the second instruction and so on. So parallel processing was a big challenge in case of the von Neumann architecture. Instructions stored in the same memory as the data can be accidentally rewritten by an error in a program. So there was a possibility where the overlapping of data can be done because they were occupying the same amount of memory. So these were some of the disadvantages of the Neumann architecture. First was parallel processing. Only one instruction or information can be accessed at one time, and instructions stored in the same memory can be accidentally rewritten. So you can overlap the instructions that are stored in the memory by an error in the program. So in order to overcome these disadvantages of the Neumann architecture, the another architecture, which is called as a Harvard architecture, was being developed.